In lesson 4.4, we're going to be considering the right triangle. So a lot of this may seem familiar to you from another math course, but we're going to be solving a right triangle, looking at our cofunctions, and actually going through a step-by-step procedure for solving a right triangle. We're going to be using these definitions that are listed here about the sine of an angle, cosine, tangent, and their reciprocal functions, cosecant, secant, and cotangent. And the way these are defined is in relationship to the angle itself. So for angle A, the side opposite would be directly across from that, which would be this segment BC. And then the hypotenuse is always the longest side in a right triangle, or the side opposite the right angle. So anyway, we're going to kind of delve into that some here in this particular section. Our procedure for solving for a right triangle is, first of all, it helps to see a sketch. So I would suggest doing that. Sketch a right triangle, label what you know and what you don't know. Then you want to express each of the three unknown parts in terms of the known parts, and then solve for those unknown parts. I know it sounds kind of ambiguous there, but we're going to get into it. And then you want to check your results. Some things that you always want to remember is that the sum of the angles should always be 180 degrees. If one side is given, check the computed side with the Pythagorean theorem. Okay, so that's a useful theorem from our past that we can use to kind of check things out. If two sides are given, check the angles and computed side by using the trig functions. Okay, so and these are the situations that we have to work with, given an angle and a side, or given two sides, or unknown parts in terms of known parts. So let's look at some things. In a right triangle, here's our little drawing of a right triangle. We want to be able to label things, and even if they don't tell us it's a right triangle, when you see this little box drawn here, automatically that's a right triangle, a right angle. We want to label the angles with uppercase letters, and typically we save the capital C for the right angle. Okay, so we save that one for this, and then A and B are the two acute angles. Then we want to label the sides with lowercase letters, but we want to be careful about this. The side opposite angle A, this one here in the yellow, we want to lowercase a. The side opposite angle B, this one here in the green, we want it to be lowercase b, and then the hypotenuse, the side opposite the right angle, is lowercase c. And the hypotenuse is always opposite the right angle. Now, when we get ready to look at an adjacent side or an opposite side, we're talking about the legs here, and the legs being that lowercase a and lowercase b, we need to look at the angle that it's referring to. So if I look at angle A, and I say, okay, what is the opposite side? Okay, it's going to be this one here in the yellow, the lowercase a. And the adjacent side then is going to be this B, because C is always the hypotenuse. Does that make sense? I hope so. In focusing on an angle like angle B, the opposite side would be this lowercase b. To angle B, the adjacent side would be lowercase a, and the hypotenuse is always C. It's opposite the right angle. Okay, and one fact that we also don't want to forget is that angle A and angle B are complementary. That means their two measures add up to 90 degrees because all three angles in the triangle have to add up to 180 degrees. And that's designated here. The trig functions is actually a ratio of different sides in the right triangle. There's three basic ones that we focus on: sine, cosine, and tangent, but then we also have the reciprocal functions that we want to consider as well. So the sine of an angle, now notice this angle is designated as theta, is the opposite side over the hypotenuse. The cosine of that angle is the adjacent side, the side here over the hypotenuse. And the tangent of that angle theta is opposite over adjacent. Now, sometimes it might be a little bit hard to keep that straight because you've got opposite, adjacent, hypotenuse, all those words that you're working with. So you might want to use a little device. And the device that I've put down up here is SOHCAHTOA. It's like we're looking at just the first letter for the word sine. This is the first letter in opposite, and this is hypotenuse. So the sine of an angle is opposite over hypotenuse. And then the cosine, C, would be adjacent over hypotenuse. And then the tangent would be opposite over adjacent. Kind of help us remember that. I know I've had some students in the past say, well, SOHCAHTOA, that's still kind of hard to remember, but you might remember it with a mnemonic device. And one that I've seen used is some old hippie caught another hippie tripping on acid. I don't know if that's the one you want to use, but there are several devices out there. In addition to that, to these three basic ones, we have the reciprocal functions, which just means, if I take the reciprocal of sine, that's cosecant. So I'm just flipping this fraction here. And the reciprocal of cosine is secant. And the reciprocal of tangent is cotangent. And let's see. And each of these represent a numerical value because we're looking at a ratio of lengths of segments. So we're taking a number, dividing it by a number. So the sine of some angle is some number, numerical value. Now, the example that I've got here is an interactive one. And what we're going to look at here are the ratios of these different sides. So if I looked at angle B here is 30 degrees. And the opposite side, they tell me, is 3.14. The hypotenuse is 6.28. So up here at the top, the sine would be 3.14 over 6.28, which is what they have here, which reduces down to 1/2, or 0.5. And then the cosine is the adjacent side down here, that 5.44. Put that over the hypotenuse. That's what we have here in this fraction. And that gives us 0.866. And then the tangent is opposite over adjacent. Now, and these are just the reciprocals of those numbers. So I'd like for you to notice what happens as we go through this little interactive video. As the videos run, these angles are complementary. They add up to 9 degrees, but those trig ratios remain the same. This number right here for the sine, cosine, tangent are going to stay the same for angle B, which is the 30 degrees. Okay, so let's play that. So even as the triangles get larger, the sine of 30 degrees still is 0.5. And even if the triangle is much smaller. Now, if I change the angle and look at angle B as being 45 degrees and look at the sides, notice here the ratios still stay the same. The sine of 45 degrees is 0.707. Okay. See that here? And then the cosine is 0.707. And then the tangent is opposite over adjacent. So that ends up being 1. Okay.